Lab 1 charge tape. So let's get started. Alright, so here's an introduction. So the purpose of this lab is to observe the interaction between charged objects, in this case tape, and determine how much extra charge is on a piece of the charge tape. So here are my results and some calculations. So we measured the charge on the tape on the observed model to be 1.6, 10 to the negative 8 coulombs, and the charge on the computational model to be 1.9 times 10 to the negative 9 coulombs, and the tape is positively charged. So we measured the number of electrons lost by each tape to be 9.3 times 10 to the 10. And here are my work on the side. So I didn't label every single step, but the formula used I will be showing you. So here are some fundamental physics principles. It's also what I used on the previous slide to get my calculations. So I use Newton's second law, which says the acceleration of an object correlates to the net force, which is commonly known as F equals ma. And then Coulomb's law explains the force between two charged particles, which looks similar to the gravitational force. And then you see here is 4 pi epsilon 0, which can also be known as K. That is 9 times 10 to the power of 9. So I have the formula here. And then Q1 is Q2 is the two charged objects, and then D squared is the distance between them. And so the lab, we calculated the system to be the suspended tape and the surroundings to be the tape that we hold on to. And then we got our initial conditions to be the following. So the mass of the tape, we got 0.002 kilograms, the tape length to be 0.2 meters, the tape width to be 0.02 meters. And then this is just a picture of us during one of our trial runs. And then these pictures are over here, shows the instructions of the lab. And then this is my glow script code. And then so here I listed out my initial conditions, and then I listed out some of my glow script settings slash background. This is my calculations, and then here I printed my results. And then as you can see here. And so we made several assumptions in the lab, both in the computational model and the observed model. So one thing we did was that we didn't account for air resistance, although the room was very negligible in air resistance. Nevertheless, there is still some. And then we treated the tape as a point charge, and we calculated it in a way that assumed that each charge tape has the same amount of charge, and that is evenly distributed. So, of course, since our fingers are on the ends of the end of the tape will probably have less charge than the middle. And so we did make an assumption that the tape was evenly distributed. And then that also leads to skewed data, as two people also pulled the tape. So one person pulled the tape that attached to the wedges, and then one person pulled the tape that was moved around. And those people pulled off at different speeds. Of course, pulling it off faster creates more electrons on the tape. Pulling it off slower creates less electrons on the tape. So let me draw out some conclusions, and then I want to go back on some of the things. So in conclusion, my computational model was in a good range of error. The charge tape can be treated like point charges. All right. And then once again, the lab, we took many test runs until we were satisfied with the results. And we went through many iterations. So at first, we made some changes, like we put the tape on the edges, like here, instead of on the middle. And then we played around with different box widths. And then, yeah, and then so we were overall happy with our results, and it took many attempts. Okay. Yeah, so that is it for my lab one. Thank you guys so much for listening. All right, bye.